So basically, how we defined as statistics. In 1822 or 1911, Francis Galton, he said that statistics are the only tools by which an opening can be cut through the formidable tickets of difficulties that pass the path of those who pursue the science of man. And but Benjamin in 1804 to 1881, he said there are three kinds of lies. Already, whatever lies we said that damned lies and the statistics. So basically, actually, it is only a probability or whatever we got as it is an approximation only. So, what are statistics and what are they used for? Basically, statistics are used to characterize the data. It is an analysis used to distinguish between a randomness and meaningful variations. And when we are using in the labs or in the mathematics or in any field, so statistics to monitor and verify method performance and interpret the results means in case of the if we are doing in the laboratories for the clinical test, so related to that and in the similar field, whatever wherever we are using accordingly we are using or interpret the results in that field. So this is a famous quote by the Einstein: do not worry about your difficulties in mathematics, I assure that mine are greater. So here's the famous quote by the Albert Einstein. And he always said that after that, he said that I don't believe in mathematics. So these are the things. So that's why, because he said that I don't believe in mathematics. So he gave a something about the statistics. So before going to the statistics, we are going that when we start our statistics, so we have some sample, and based on that sample, we have some population. So some population is given, and from that we are selecting some elements that is known as a sample. So like the bigger circle is your population, and from that we are selecting some randomly. So those are known as a sample. Suppose we are starting with I'm taking a simple example. There are the two classes, and the IQs of the different students are measured on those classes. So class A is IQs of 13 students, same way class B IQs of 13 students. This is the individual data is given. Now, if someone asked you that which group is smarter or which class is smarter, we know that every individual is different. So these are the IQ levels. If we try to understand a group, then we have to find out that how to understand the group. What is the quality and how we say that which group is smarter. So what we are doing, we start that we find out the average of the both the classes. Now what do you mean by average? Average means the mean. So you add all the data of class A, divide by 13, same way class B and divide by 13. Now you see the average is almost the same. It is 110.54, there it is 110.23. So they are roughly the same. So with this you can't judge that which is the smarter now. So it is not easier to answer this question here. So we go to the further, and then we are using the different types of the techniques. So what are these of the descriptive statistic? We organize the data either in the tables form or in the graphs form. Then we summarize the data using central tendency or variations. When we are doing the organizing the data, so we are going to the frequency distribution, then the relative frequency distribution, then cumulative, and there are the different ways which already you know that. Same way when we are doing the graphs, we are doing a bar chart, stem and leaf or frequency polygons, and there are the different techniques which we are using. When we are trying to summarize the data, we calculate for the central tendencies, mean, median, mode. When we are taking a variation, so we are taking range, interquartile range, variance, standard deviation. All these are just to recall all these purpose, which already you know that one. So what are the basic concept? Basically, an experiment is the process by which an observation is obtained. Experiment is, suppose we are taking a record and is toss a die, then record an opinion. Toss a coins means instead of a one coin or two coins. Now, what are the basic concept about the probability? If we are coming to be a simple event is the outcome that is observed on a single repetition of the experiment. The element to which means probability is applied. One and only one simple event can occur when the experiment is performed. A simple event is denoted by E. So if you are taking E, simple event will be denoted by a probability and it denotes how often it occurs. Suppose I am taking a tossing of a die. So how often the tossing, when we are tossing a die, one will occur. So same way two will occur or the three will occur. These are the events. Same way, if we are collecting all these experiments, the set of all sample events of an experiment is called the sample space. Suppose we toss a die, then there are the 6 events on a die. So sample events are either 1 or 2, 3, 4, 5, 6. So event 1 is when it is coming to be 1. Event 2 is when it comes to be 2. And like this, E6 is when it comes to be 6. If I'm taking a sample space, so it is a collection of all these events. So it is E1, E2, E3, E4, and E5 and E6. And this is the complete your sample space. Now, if we are collecting this sample space, so now from this sample space, you are collecting an event. So an event is a collection of one or more simple events. Suppose we are taking a die and A is an odd number and B is a number greater than 2. So now if we have to find out the probability or event, what are the events now possible? Because it is an odd number, so 1, 3, 5 are possible. And since it is a greater than 2, so this means only 3 and 5 are possible. So A is either E1, E3, E5. And when we are taking a B, so then it is E3, E4 and E5, E6. Now, these are the two events which you are taking as a from the simple events. Now, if we are calculating these two events, so these two events are mutually exclusive. If one event occurs, the other cannot, and vice versa. Suppose we are tossing a die and we observe that first event is an odd number, second is a number greater than 2, third is a observer 6, and D is a observer 3. Now, if we are taking all these four experiments, if we are taking first two as a combination, so what is we are getting that? Because these are not mutually exclusive, A observe an odd number, so these are the 1, 3, 5. B is the observer number greater than 2, so it is 3, 4, 5, 6. And if you are taking a both, so 3, 5 is common in the both ones. Now, if you are taking the last two, observer 6 or observer 3, so these are the mutually exclusive event, because if it is a 6, then it is not a 3, and if it is a 3, then it is not a 6. So if we are taking a B and C, now B is a number greater than 2. This means 3, 4, 5, 6. And when we are taking C, so observer 6, so that is not mutually exclusive. If we are taking B and D, then again it is not a mutually exclusive event. So how we have to find out the probability of an event? It is defined that how often it occurs, and we write it as a probability of A. Suppose that an experiment is performed 10 times, then the relative frequency for an event is number of times A occurs divided by the n, means it is F by n. So F is the number of times that occurs and n is the total number of events. If n is large, and this is the axiomatic definition basically, if we get n is very large, then what will be the value? Then it tends to 0. This means if we are having a n is very large, then probability is defined as limit n tends to infinity f by n. So this means whatever be the number, if f is a small, we are getting a values as a approximate to be 0. So these are the different limitations also on the case of the probability. And this probability starts with the gambling, because at that time they are try to find out what are the chances to winning a game. So it starts with the gambling, then it goes to the games. But now with the development of the set theory, this probability comes to be the axiomatic, and which is based on which your computers and others are designed. So nowadays we are using a set theory, and computers is calculating based on the set theory. So probability of A, because maximum it will be a n value and the minimum is 0. So it lies between 0 and 1. So this means if event A can never occur, so we said that it is an empty set and the probability is 0. If event always occurs, then always that complete experiment performed and the probability is 1. If we are taking a sum of the probability for any event, then it is always equals to the 1. So probability of an event is found by adding the probabilities of the all the simple events contained in this. So how we are finding a probability? Suppose we are tossing a coin. So we are as Miss probability is using empirical studies, then estimated based on equally likely events. These are the assumptions basically. Suppose we are tossing a coin. If we are tossing a coin, there are the only two possibility, either head is there or tail is there. So this means if we are taking only head, its probability is half. Same way, if we are taking 10% of the US population has red hair, so now we have to select a person at random. So of course, probability of this is 0.1 only. So this way we are finding the probability, which is nothing but whatever be the event is given divided by the total number of events. If we are tossing a coin twice, so what is the probability of observing at least one head? So if you want to calculate the probability of at least one head, so there are the chances as that head tail or tail head or both the heads. So if we are taking or making a table, so at first coin, suppose it is head or tail. Same way tail, second coin, it is a, if on the first coin it is a head, so there are the chances head and tail or head head. And same one second way is tail head and tail tail. Since tail tail is not possible, you required at least one head. And if you are calculating the events, it is HH, HT, TH, TT. And if you are calculating the probability of each event, then it is 1 by 4, 1 by 4, 1 by 4 of each event. And now if we have to calculate our probability, so only three possibles. So at least one head is probability of E1, E2 and E3. So it comes out to be 3 by 4. So this means if we are having a probability, same way if I want to calculate the probability of no head, so of course it is 1 by 4. Like this you can make a different combinations. Suppose we have a bowl contains three types of the chocolates or then one red, one blue and one green you have to select. A child selects two at a random. So what is the probability that at least one is red? Now these are the cases. So red is only one, blue is one, and there are the two green and sorry, one green. So second chance is that with red you have a blue or green. Same way with blue you have a red or green. With green you have a red or blue. So these are the possible. So if you are taking an event, these are red and blue like this one, and the probability of each is 1 by 6. Now you have to take what is the probability at least one is red. So first case, second case, third case, and then the fourth case. So if you are taking a probability, it comes out to be these four cases, and it is 4 by 6 or 2 by 3. So these are the simple methods which you are using or you know already. Now, what are the different rules? Already I said that it is a counting rule, total number of simple events divided by the total number of events. What is the MN rule? If an experiment is performed in two stages with M ways to accomplish in the first stage, n ways to accomplish in the second stage, then there are total mn ways to accomplish the experiment. And this rule is means how many numbers you have the experiment trial, and it is extended to n1, n2 like this up to nk. So suppose like earlier example we take as the total events are 2 into 2, which is 4. So in total, if you have a whatever be the number of that, you have 2 to power that number, you have that total number of the cases which are favorable, which are there. So suppose we are taking again, we are tossing the 3 coins. So of course the events are 8. When you are tossing 2 dice, so it is 6 into 6. So total is 36. Same way like you are taking a dish containing 2 red and 2 blue candies. So the total is, because 2 red and 2 blues, so total are the sample events, 2 red and 2 blues. So candies, so total is 4. And because you are selected one, so in the second trial it is only the 3. So first, in the first you have a total 4 candies, and in the second you have only, because already you selected one, so it contains 3. So total are the 4 into 3, 12 events. The number of ways we can arrange n different objects taking r at a time is simple. We are using the permutation. It is n factorial over n minus r factorial. Suppose 3-digit log combination can be formed out of the number 1, 2, 3, 4. So total are 4 factorial. So how many choices are there? 4 factorial. 4 minus 3 is 1. So total 24 is possible. Same way, a log consists of 5 parts and can be assembled in any order. And as a quality control engineer, you want to test each order for efficiency of the assembly. How many orders are there? Since because the choice is in what manner you are taking, total are the 5 parts. So 5 factorial, and you are selecting for all. So n minus r is 5 minus 5, which is 0. So it comes to be 120 ways you have to select that. Same way how to plant or how to generate about the telephone lines. So there are so many application in the different field. Same way now if we are want the number of distinct combination of n different objects that can be formed, but taking them r at a time. So then we are using a combination like 3 members of a 5-person committee must be chosen to form a subcommittee. How many different subcommittees can be formed? Then the order is 5 factorial, and since you are selecting a 3 persons, so 3 factorial over 5 minus 3 factorial, so it comes to be 5 factorial by 3 factorial into 2 factorial, and it comes out to be 10. So this means with these 5 persons and choosing a 3 subcommittees, you can make a 10 subcommittees. Same way again we are taking 4 red, 2 green, child selects that, then what is the probability that it is not a red, that exactly one is a red. So total are 4 plus 2, 6. So in the first case it is 6. When a candidate is selecting a 2, so 2 factorial over 4 factorial. So the total is the 15 ways. And now you have to choose the 2 out of these ones. So this means C1 is 2 factorial. So ways to choose, one green is out of 2, one way is there. So same way out of the 4 red, you have to select one red, which is 4. So total, if you are taking, total are 4 into 2, means 8 ways to choose one red and one green. So total probability is 8, and the total cases are 15. So it is 8 by 15. So these are the simple examples which you have to calculate, that how to find out the total probability in case of these. Now how to find out the relations about that? The union of two events is either A or B or both of these, and it is denoted by A union B. So if any set A is there, any set B is there, so there are the A, B, and the some portion which is common. So if I have to find out the probability of the complete one, then it is how to find out. Same way intersection if you have to find out. So this means this is the portion which is an overlapping between the two. It shows the intersection part. So if two events are mutually exclusive, this means they don't have any common part, then probability of there is 0. Same way if we are coming to the complement, then it is a total universal set and minus of this set, and it comes to be the A complement set. Now suppose you have to select from the classroom and record the hair color or gender. A is the student has brown hair, B is the student is female, C is the student is male. Now what is the relation between events B and C? So if we have to find out the A complement, what is that A complement? So B and C, you know that these are the mutually exclusive event. So B equal to C complement. A complement, if we have to find out, student does not have brown hair. B intersection C, of course it is an empty set. B union C, it gives you the all students, which is a complete sample space. Now there is the how to find out the formulas or the probability. So firstly, we are using the additive rules. So if any two events are given, the probability of the union is simple probability A plus probability B, because this intersection is in the both is common and it is occurring twice. That's why once we are subtracting it. So it is this portion which we are subtracting. So this is the probability or additive rule for unions. And if we are taking like a brown hair and like these ones, and we are finding that A is the brown hair, so probability of A as a brown hair is total male and female are 50, and the total ones are student in the class is 120, so it is 50 by 120. If we have to take only female, it comes out to be 30 plus 30, total are 60. So probability of a female is 60 by 120. And the same way, the probability of A union B is probability of A plus probability of B. So 50 plus 60, and the probability of intersection. Probability of intersection means it is a female, the candidate is a female and also have a brown hair. So it is a 30. So it comes out to be 50 plus 60 minus 30, and it comes out to be 80 by 120. So total is, if we are taking B's plus 3 plus 30, again it comes to be same way. When two events are mutually exclusive, then probability is 0. So probability of sum is probability A plus probability of B. Now A is the male with brown hair. So probability of males with brown hair is 20 by 120. B is a female with brown hair. So it is 30 by 120. Now A and B are mutually exclusive. So total probability of brown hair is 50 by 120. So if you have to find out the probability for the complement, so we know that the probability of A and A intersection of A complement is, because both are mutually exclusive, so probability is 0. Since either A occurs or A complement occur, so it gives you the complete sample space. If we are taking union, it comes out to be 1. So probability of A union A complement is 1, and which is defined as a sum of these ones. So probability of A complement is nothing but 1 minus probability of A. Now suppose again I have taken the simple example. So probability of male is 60 by 120. Probability of female, since A and B are complement, so probability of B is 1 minus probability of A. So it comes out to be 1 minus 60 by, it is 60 by 120. So now if you have to calculate the probability of the intersections, so the independent and the dependent events comes to be, if probability of A intersection B is equal to the probability of A into probability of B, then we are saying that these are the independent event. This means if the probability that event A occurs does not change or depends on whatever be the probability of B occurred, then we say that these are the independent events. So probability, conditional probability, when we are talking to be that, this means probability that A occurs given that B has occurred is called the conditional probability of A given B, and it is defined as A conditional B, which is defined as probability of the A intersection B divided by probability of B, provided probability of B is non-zero. And if these are the independent events, in that case it is equal to, because probability of A intersection B is a product of that, so probability A into probability B, and probability B is non-zero. So in that case conditional probability is equal to the probability of A only. Now suppose we are taking A is the head on second toss, B is the head on the first toss. So these are the event HH, HT, TH and TT. Now what is the event A? So if we are taking this one, so probability of A conditional B is head on the second toss, means head on the second toss, and B is the head on the first toss. So the cases are A intersection B. This means A intersection B is the event which is favorable to that only one, and the total are, because you are taking a probability, so it comes out to be the 1 by 2. Same way A not B is 1 by 2. So probability A does not change whether B happens or not, then we say that it is an independent event. Again, the candy example is there. Suppose you have 2 reds and 3 blues candies, and you select any 2 candies. So A is the second candy is red, B is the first candy is blue. So if you are taking a sample space, it is probability A condition B, because second is red. There are out of 2, so 2, and the total is, because you have selected the first one or the intersection, so it comes to be 2 by 4, which is 1 by 2. And again, not of that is 1 by 2. So this means probability A here changes with the depending on whether B happens or not. So they are dependent variables because it is not an independent variable. Same way we defined in terms of the conditional probabilities. So probability of A condition B is probability A, or B condition A is probability B if they are the independent event. Otherwise, they are the dependent event. So we have to define according to the intersection either or by the conditional as per whatever be the way it is simpler to calculate. Multiplicative rule for intersection is for any 2 events, the probability that both occurs is probability A intersection B is probability A into probability of B conditioned A. So whatever you are taking the first, that comes to be the second one. And similar way, if you have an intersection, if they are the independent, you have the probability as a multiple of probability A into probability B. Now it is suppose 10% of the people can be classified as high risk for a heart attack. 3 people are randomly selected from the population. What is the probability that exactly one of the 3 are at high risk? So there are a H means at high risk and N means not at high risk. Now if you are taking a percentage, it is a exactly at high risk because there are the 3 peoples, and you have to there that exactly one of there are at high risk. So high risk and not in that, and you are making a combination of that. And if you are taking a probability, it comes out to be the product rule, pH into Pn into Pn. And accordingly, if you are taking probability of at high risk is 1 by 10. So it is 0.1, 0.99 like this thing, and you are calculating, it comes to be 0.243. Same way, only 49% of the population is female. Also of the female patient, 8% are at high risk. So what is the probability that it is a high risk female? So again, the same way, probability of female is that, so high by female is 0.08. So if you are taking a productive multiplication rule. So high risk female is probability of female into H condition phi. So it comes out to be 0.0392. Now the law of total probability. Suppose there are the mutually exclusive events, and the probability of event A can be defined as A intersection S1 plus A intersection S2 divi- up to probability A intersection of Sk, and the sum is given as probability of S1 into probability of A condition S1, and like these sum. So if you are taking like these are the different ones, and this is the event. So how much it is occur in all the events? So it is taking as A intersection with Sk, like these ones. So the total sum is like this, which already I showed you, and which is showed as this one. Now we are coming to the Bayes theorem or Bayes rule. Here it is given there are the three conditions. All the events which you are taking are mutually exclusive and exhaustive. What do you mean by exhaustive? Means the total union should be one with prior probabilities as all these probabilities which are the positive probabilities. If any event A occurs, then the posterior probability of Si given A is occurred as probability of Si conditioned A is probability of Si into probability of A condition Si divided by the total sum or probability of all the events A. So this is the Bayes rule. And suppose I'm taking that, what is the probability? A single probability means there are the 8% are a high risk for heart attack in case of a female patient, and for male patient it is 12%. A single person is selected, and we have to find out it is a high risk. What is the probability that it is a male? So if we are taking again, so probability of female is 0.49, probability of male is 0.51, probability of female patient at high risk is 0.08, and same way 0.12. Now we have to find out m by h, and when we are taking probability of male we know that 0.51, h condition m is known to us. The same way when we are calculating 0.51 into 0.12 divided by this, it comes out to be the 0.61. This means the probability that the person who is at high risk and a male, it comes out to be 0.61. Now, how we defined a random variable? A quantitative variable is said to be random variable if the value that it assumes corresponding to outcome of experiment is chosen as a random event. Now, if we are finding, it can be either discrete or continuous. Suppose we are taking a set score or the any score of a randomly selected student, number of people in a room, or the number of people joined this event. So these are the all examples as a random variable. So the probability distribution for a discrete random variable is the relative frequency distribution, and it is a graph, table or formula, and that gives the values of x with the probability. So in case of the probability distribution, it lies between 0 to 1, and the sum of all the probabilities is 1. Suppose we are tossing a coin 3 times and the number of head. So these are the events or the random variables, and the probability corresponding to each is the 1 by 8. If you are summing of all these, so all are greater than 0 and the sum of all is 1. So you are taking that the event x bar is 3, means the 3 heads or the 2 heads or the 1 heads or the 0 head. Now if you are finding the probability corresponding to that, so if you are having 3 head, the probability is 1 by head. If you are having a 2 heads, so that is 3 by 8. Same way 1 head, it is 3 by 8, and the 0 head, it is 1 by 8. And if you are summing all this probability, it comes out to be the, this is a table for random variable corresponding probability function, and the sum if you are taking, then it is showing it is 1, and this shows the histogram of that probability. This means at the 0 you have a 1 by 8, then 1 and 2 you have a 3 by 8, and the last you have again as a 1 by 8. Now the probability distribution, as we are saying, it is a shape, outliers are there, then you have a center and spread. So when we are talking about the shapes, it is a symmetric, skewed, mount shaped. Outliers are unusual or unlikely measurement. Center and shapes, this means mean and standard deviation. So in general, we are defining a mean population as mu and the standard deviation is sigma. So if x be a discrete random variable with probability distribution px, then the mean is given as mu, which is summation of x into px. Variance is sigma square, which is summation of x minus mu. Means we are taking a deviation from the mean, so it is x minus mu ka whole square into px. The standard deviation is simple of under root of or positive square root of the variance. So if you are taking or tossing a fair coin 3 times and record the x number of the head, then you are getting this is the probability. So xpx 0 and like this, if you are calculating 336, so it comes out to be mean is 12 by 8, which is 1.5. Variance is this value, and when you are calculating this, it comes out to be 0.75 and the standard deviation is 0.688. Same way, number of head in tossing 3 fair coins. So these are the shape outlier. If we are taking the shape of this, it is symmetric and mount shaped. Outliers are unusual or unlikely measurement. As we are saying, because it is a standard deviation, so it is how much it is a spread 0.688. So um, in total, if we are talking, so there is the probabilities are there, the sum of the probabilities are there, and these are the rules which we have defined already. And random variable. Now, what is the basically if you are taking any rule, if there are the two variables, then we are coming to the relation between those, and it is known as a correlation. Now, what is the different type of the error? Suppose it is a complete sample, and from this we are selecting some statistics. So complete sample is this one. From that we have selected the statistics, and this statistics of course depend on the that variable can be generalized from small n to the capital complete N. So it is a sample distribution depends on that what kind of sample we are taking. So this error is an important error. Then there are the different type of the hypothesis. Either it is a null hypothesis or alternative hypothesis. Null hypothesis means A equal to B, and alternative hypothesis is A is not equal to B. So how inequally are these observation? Are these observation reflective of general population? So if we are finding, how we have to find out, is there any difference in the length of time that males and female can sustain in an isometric muscular contraction? So null hypothesis is both has the same value, and the null hypothesis it is different. So these are the different type of the hypothesis. So there is a significant difference. This is the null hypothesis. Alternative hypothesis is there is not a significant difference. So these are the two type of the hypothesis before testing any data. And when you are taking these are the two-tailed hypothesis, because most common and most recommended are these ones. This is the analogy how we are doing that. Uh, uh, this is nowadays we are using this statistic, not nowadays, earlier also we are using in the legal processes also. Suppose you are the prosecutor and you have to defend that it is not guilty or guilty. So your job is to provide sufficient evidence in case of that. So how to find out this one? So these are the different types of the length of the these scales. male and female, and that samples is the small one. This is the sample. Now you see that your sample and the complete is the almost the same one. So this is known as the sustained isometric torque, or the how to find out the Gaussian ones. Here, if you are taking this type of the sample, you see that it is not matching to this. So it is a poor type of the sampling. So important is how we are taking a sample. So there are the different type of the error. Type 1 error is that we are rejecting the hypothesis when it is actually true, concluding that there is a difference when one does not actually exist. Type 2 error is accepting when it is actually false. So there is concluding no difference when does exist. So error 1 can occur due to the biased or inadequate sampling, poor experimental design, or the use of inappropriate or non-parametric tests. So what are the independent measures? Individual scores in each data set are independent of one another, repeated when it is dependent on the other set. So either it is paired or correlated. So if we are taking a testing, so of course there is the hypothesis is required. Already I said that. Then you are have to find out that whether you have to check that data, or how to reject that, or how to find out the conclusion out of this. Suppose a pharmaceutical company is concerned that it is to find out the mean potency of the antibiotic. So they need to divide between two possibilities, that does not exceed the required minimum potency, or it exceeds to the minimum potency. Now this is a how to sample this hypothesis. So this means null hypothesis and the alternative hypothesis. Identify and calculate the tested statistics, then to find out the p-values, make a decision. So this is the basically to check any critical test. Null hypothesis already I explained, alternative hypothesis. So in this case, the earlier one, like a court trial, either it is innocent or guilty, it exceeds the potency or it is required potency. Same way, if you are having any ball, you have to produce a mean of this centimeter. So it is 6.5 or is not equal to this one. So it is a two-sided or two-tailed. Same way, the concern could be selling the consumer less than 0.75 kilogram of peaches. So it is greater than equal to, or it is less than 0.75. So because it is only one-sided. So basically, when we are using the distributions, so value attached to the equal sign, then there are the two cases, either it is greater or less than. Same way, when we are taking hypothesis, so this is not always possible. So there are the two possibilities in the making of decision. Either we reject or fail to reject, which is a null hypothesis. When we say that it is fail to reject, this means we are accepting the null hypothesis. Like now I am taking a simple example that reject the null hypothesis when it is true. So like a jury decision, either it is guilty or innocent. Actual fact is it is guilty or innocent. If it is guilty and guilty, of course it is a correct. If it is guilty and considering an innocent, this means there is a error. Same way, innocent and guilty, so there is a error. Innocent and innocent, of course it is a correct. So if you are calculating it, in this case, if it is true, of course it is correct. Otherwise, if you are rejecting that or H0 is false, then you have a type 2 error, otherwise a type 1 error. So these are the error analogy. I'm coming to the, I'm not taking this one. I'm coming to the, whatever be the main I want to show you, and the main types of these. Yeah, because you are using a distributions, and this is which you are using in nowadays in the binomial. Here are the suppose theta and 1 minus theta, means theta is the probability of up, 1 minus theta is the probability of down. So if you see this experiment, there are the 8 up and 2 down. So it is 0.8 and it is used in the maximum likelihood. Now you are using in the Boltzmann machines also, this type of the techniques. So like this, if you are taking a probability of the, so it is the chance probability of success is P, 1 minus P. And if you are calculating, this is the data. And this shows the Gaussian curve. And based on this, I simply want to show you that how we have used this type of the distribution. And same way we used in the Monte Carlo methods also. Here Monte Carlo method is basically a square and a circle. So if you are finding the area of a square, it is x into y. So x square in case of square, area of circle is pi r square. So total pi value is 4 into area of circle by area of square. So this is the Monte Carlo method. Hmm. This I want to show. These are the phantoms which are generated in the lab, and here we are using the finite element methods, Bayesian methods. Bayesian is based on the. I have shown you that how to find out based on the binomial ones, and these are that how the signal travels and where we are using this type of the techniques. And this is a support vector machine which we are using to segregate the two different types of the datas. This is the fuzzy where we are again using this type of the techniques. Uh, and this is a artificial neural network. And on based of these ANOVA and artificial, these are, here we are using this technique. And this is that right now in the reproduction number, in the case of pandemic, I'm coming directly to the equation because we are running short of time. Yeah, this is the basically we are using this time series analysis, and using this time series analysis, we have find out that this pandemic will be over around 451 days. And these are giving that if you are coming in contact, you have a cycle of that suffering from this. And this is a paper which is published in a Chaos Soliton. And in this paper, we have used the different techniques like a wavelet method, artificial neural network, fuzzification, and based on these, we have developed this new model. And we find out that, and this is the result. Exact result is the giving the number of the suspected as a 41, and with our method we got a result as a 42. And based on this, when we find out that this is that the end of the epidemic in India is roughly approximate between April to May 2021. So these are the techniques which are giving you the different type of these types. So in short, if I can say that whenever you are using or teaching or research or study, always have a positive attitude, be honest, be motivated, do sincerity, means whatever you are doing, be sincere in that, always be inspirational, committed towards your job, do hard work and be integrable. So success has only one amazing formula. Stop thinking in terms of limitation and stop thinking in terms of the possibility. So I am always doing that which I cannot do in order that I may learn how to do it. And you can contact for any queries. Thanks for listening.
Thank you, Neha. It's an honor to have been asked to offer a vote of thanks on the occasion of expert lecture. On behalf of Medicap University, I extend my gratitude to our today's expert, Dr. Rashmi Bharadwaj ma'am. Ma'am, thank you so much for your valuable time. It's an honor and privilege for us to have you. Thank you so much. I would like to extend gratitude to our Honorable Vice Chancellor, Dr. S.K. Somani, for sparing his valuable time. His kind suggestions and motivation are always inspired us to such programs. Thank you, sir. I am thankful to our respected Dean, Dr. Preeti Jain ma'am, for her continuous motivation and support. I would like to thank convener of this program, Dr. Pranjali Kekre ma'am. Because of her efforts, this lecture took place. Thank you, ma'am. I would also extend thanks to all faculty members of the department for their support and contribution. I would like to thank our registrar, Dr. Yadav, for all his backup support. A big thanks to our technical team, Mr. Surikant and Ms. Amrita Mantri, for all technical support and smooth conduction of this online lecture. Last but not the least, thank you all participants for attending this lecture. Thank you so much. This is Dr. Rekha Jain from Madagascar University signing off.